Hello everyone. In this video I am going to have a discussion on Siemens S7 300 PLC. As you can see here, this is the Siemens S7 300 basic PLC. The full PLC comes like this in a single package. You can see this is the Siemens S7 300 PLC. This is the Siemens PLC S7 300 model, S7 300 family. So the model number of the CPU is CPU 313C. You can see here it is mentioned CPU 313C. So this is how the CPU looks like. So there is a memory card on the CPU. This memory card is responsible for holding the memory. All the program memory will be inside this memory card. So you can see here, this is the Siemens S7 300. It is written here, and these are the three states of the PLC. This is the run state, this is the stop state, and this is the MRES, memory reset state. So when we are programming the PLC, we have to put the PLC on stop state. We have to keep the switch on middle state, and then when we are resetting the PLC, we have to bring the switch down. See, this is a retractable portion. This portion is retractable. Once it goes to MRES, it will come back to stop mode. See, I am pushing it. It is going to MRES. It is coming back to stop mode. And after we finish, when we are willing to run the program, we have to push it to the run mode. Normally, always the PLC is in run mode only. When we are interfacing the PLC with the computer, that time it will, when we are loading the program, that time automatically the PLC will go to the stop mode, and then it will ask whether we want to bring it to run mode or not. Then in that case, we have to bring it to run mode from the software. So we don't use this switch much. Only in order to reset the PLC, we are using this switch, or if we want to stop and restart the PLC, we are using this switch. Mostly this switch is in run state. So these are the status LEDs in the PLC. So this SF means the station fault. If there is any station module here in this rack, so presently there is only this PLC is there. If there is any fault is there, system fault, any fault in the PLC or any other devices in the rack, if there is any fault, then it will be displayed here. Any fault in any IO modules or anything, it will be displayed here. This is the system fault, SF. So after the system fault, there is a DC 5 volt fault. You can see if there is a power supply fault, DC 5 volts power supply fault, then this LED will be on. So there is one more LED, FRCE. You can see this is FRCE, this LED. This is the force LED, FRCE. So in the program, when we are forcing any signal, that time this LED will glow in orange state. This is the FRCE, means force LED. When we want to bypass any instrument, that time we have to give a force in the software. That time this LED will glow. This will indicate that forces are existing in the PLC. So there is one button here. There is one LED here. This is the run LED. This LED will glow when the PLC is in run condition. And the last LED is the stop LED. This will glow when the PLC is in the stop condition, stop mode. So these are the few LEDs, status indicator LEDs. In these status indicator LEDs, the SF, the system fault, is the main LED, and force LED indicates whether there is any force in the logic, in the program. So this is how the PLC looks like. So this is the model number of the PLC. You can see here, this is the model number of the PLC, 3135BF030AB0. This is the model number of the PLC. We have to search the same model number in the software when we are doing the hardware configuration of the device. In this upcoming videos, I am going to show you how to configure this PLC. So this is how the PLC looks like. You can see the side view of the PLC. You can see it is written Siemens S7 5BF030AB0. So when we are making the hardware configuration, that time we have to search this model number. The PLC is made in Germany. You can see Siemens S7 family PLC, S7 300 PLC. This is having hazardous explosion certificate EX. We can install it in explosive environment. There are certifications of the explosive environment up to what rating, which area we can use it. So now I am going to show you the PLC from the front. So if we open this cover, we can see here this is the programming port, this is the MPI port, this is the programming port. We connect the programming cable here, and other end of the programming cable is connected to the laptop, and we download the logic to the PLC. We can force the signals from the PLC using this MPI port also. And here is the power supply connector of the PLC. This is a DC 24 volt, you can see. This is a DC 24 volt power supply. So we have to connect the power supply here. We need to be very careful on the polarity. We should not connect a reverse polarity, it will damage the PLC. So now this is the PLC. Now you can see on the PLC itself there are two modules coming. It is shipped with these two modules. It is a single unit. You can see here single unit. So this model of the PLC, is 5BF030AB0. This model comes with these two cards with the PLC, with the CPU. So here you can see this is a card, this is a digital input 8. So this card is having 8 digital inputs option, 5 analog inputs, AI5 is 5 analog inputs, AO2 is 2 analog outputs, 12 bit. So 5 analog inputs 12 bit and 2 analog outputs 12 bit. This card supports, and it also supports 24 volt DC digital input, 8 digital input channels this card also supports. You can see here the status indicators of the LEDs for the digital input, and for the analog input and analog output there is no status indicator. It will just like that occur. So you can see here. So this is how the connector looks like. See, presently there is no connector. The connector is blank. There is no connector. One connector comes here, and on that connector we have to do the wiring. Presently there is no connector. That's why directly you can see the terminals inside the PLC. You can see the terminals directly. You can see the terminals. Now here you can see there is a drawing. So if we want to connect it to the digital input switch mode, how to connect, and if we want to connect to the analog input, how to connect. See, when we want to connect it to the digital input, we have to connect the switch output here, and here should be common. And for analog input, here this is the voltage, this is the current, this is the voltage, current. So if we are using current loop, 420 milliamps loop, we have to connect the wires between 3 and 4. If we are using a voltage loop, we have to connect the wires between 2 and 4, like that. You can see a closer view. If you want to connect it in the voltage mode, 0 to 5 volts DC, then in that case connection will be 2 and 4. And if we are connecting in current mode, 4 to 20 milliamps current mode, in that case the connection will be between 3 and 4. So like this we have to do the wiring. And also for analog output, you can see this is the analog output block. This is the analog output. So this is the common terminal, and 16 is the one output, 17 is another output, 18 another output, 19 is another output. So in these 4 analog outputs, this is the voltage output, 16 is voltage output, 17 is current output, 18 is again voltage output, 19 is again current output. So this card is made accordingly. So in this way, in analog outputs we cannot change. This is voltage output, means it will be voltage output only. This current output means it will be current output only. And here this is RTD input. You can see here R symbol is there. This is a resistance input. This is not a voltage or current input. You can see AI4. See, there are 5 channels in the analog channels in the card. I have already told before. So in the 5 channels, see 1, 2, 3 and 4. 4 channels are analog input, milliamps or voltage, and the 5th channel is the resistance input. You can see R with a variable symbol is there. This is a resistance input. AI4 is the resistance input channel. So this is how the channels are on the first card. And on the second card you can see this is written DI16, DO16. That is 16 bit, 16 digital inputs and 16 digital outputs rated 24 volts we have to connect. So here we can see, if we open this, we can see here also there is no connector. Directly the base connectors, base pins are visible. So if we look here, we can see we have here 8 digital inputs, 8 digital outputs, and here also 8 digital inputs, 8 digital outputs. So 8 digital inputs here, 8 digital outputs here, Again 8 digital inputs here, 8 digital outputs here. See, digital input this side means this side, digital output this side means this side. Okay, so see here it is, they have shown it, digital outputs is on right side. So here on the right side, these are the digital output terminals and these are the digital input terminals corresponding to this. So in the same way, if we look here on the terminals, when we connect the terminal strip, there will be the terminal numbers will be there. Then that time it will be very easy to know that which wire will come to which point. So this is how the PLC looks like. Very soon I will start a programming tutorial on the S7 300 PLC. So stay tuned to my channel. And one more last thing, if we want to remove this memory card, we want to change this memory card, we have to push here. So when we push here, this memory card will come out. You can see this is the memory card. So this is how it looks like. You can see this is only 64 KB memory card. This is not a very big memory card. You can see the part number of the memory card under. See, this is the part number of the memory card, 6ES7, C6ES7953 8LF200AA0. So when we want to order this memory card, we have to mention this number to Siemens. So I'll put this card back. Similarly, if we want to order this PLC, we have to mention this number to Siemens. That time only they can trace this product and they can supply this product. So this is how the schematic S7 300 PLC looks like. This is a basic view. This is the first tutorial on the Siemens PLC. Very soon I will be coming back with many other tutorials on Siemens PLCs, including the programming tutorials. Thanks a lot. Thanks for watching.